All right, here we go. We're back. It's Monday. We are back at it. Here we go. And I've got a new setup, so I'm like making sure everything looks good. I think it was. We've got a variety of components that I'm just double validating before we jump into the topic of the day. And just taking a peek here, making sure we're all set up. But it looks like it's working, doesn't it? That looks pretty good to me. Let's see here. Clicking buttons. All right. Seems adequate. I think we did it. I think this is it. The long weekend paid off, which is great. This is fantastic. Okay. And everything is, it's just so easy now. Look at that. Computer is not computing too heavily anymore. This is great. Let me double check everything. Yeah, things are smooth. Okay. Here we are. Welcome back, everyone. Hey, MD. Hey, good to see you. We're just chatting on Discord, weren't we, a little bit earlier today? And over the weekend, too. You've got some Rust that you were working on. How did it go? Curious to see. I'm good today. Today is good. Today is Monday, and it's the beginning of the week. And what we're going to look at some more Rust machine learning, because last time we didn't finish it. And I really, really want to finish it this time. And I spent a little bit of time over the weekend and I came across one of the common problems that you have with machine learning and deep learning. And we'll go over that as well today. We'll do a little bit of diagramming. We'll do some diagramming that shows what were the problems that I ran into. So it's actually one really simple, easy problem. And it's just like you need to know this. If you're doing machine learning models and you're building AI, you need to know this one thing. It's really important. It's kind of like the foundational aspect to it. If you know this one thing, then you can probably have a pretty good time building your machine learning model. So we'll be covering some of that, and we'll also be walking through some of the code. I built out a little bit more of the code over the weekend to make sure that it can actually work. And I knew it was going to work. I just wanted to just be sure to be ready for it for you guys. So when we walk through it, we can see what that code looks like. And we have it on the screen here, actually, part of the algorithm for this is like a tool. It's like what do you call it? A toy model. It's called a toy model. The idea is it is not useful, really, but it helps describe a way that helps you understand how AI kind of works a little bit. Just a little bit. Just a smidgen. Behind the idea, because typically when you want to create some sort of equation or a model that helps analyze or predict a situation, you have to do a lot of work. As a human, you have to do a lot of work to get that model or that equation to work, and you have to test it against a bunch of data, and then you have to develop that equation yourself. But here's the good news. Check this out. This is really cool. With AI, you don't have to build the equation. The equation's built for you with a whole bunch of things called parameters or weights. These are the coefficients of the model. Essentially, Alex, hey, how's it going? Good to see you. We're going to be wrapping up the AI stuff that we didn't finish on Friday, and I really wanted to finish it. Your playlist is goldmine for learning Rust. Is it, MD? That's great to hear. Thank you. I was one of the things was the Rust by examples. The Rust by example, that was a really good learning experience for me. And so what I wanted to do was walk through those on video on YouTube and record those and then share those out, because they were such a great learning experience for me. And it's great that you say the same thing, because you have a similar experience of excellent learning Rust experience. Yeah, it's great because it helps you like learn, all the patterns, the different design patterns, match statements. What is unwrap? Why would you use unwrap? Should you never use it, or are there cases when you want to use it? Things like that. So, but yeah, today we'll walk through the AI, and then we'll actually run it. We'll actually run it here. So actually, let's take a peek here. See here, our system. Let me go ahead and close that window. We don't need that anymore. Okay, cargo. Let's see. Cargo run. I'm pretty sure I had this cargo run ready to go. Oh, okay. Oh, sweet. It's working. I just have a warning. I didn't. What's the warning about? Wait. Time out. I wanted to see what that warning is. We have to go check that out really quick. Okay. It's unused variable. Okay. Unused variable X. Where is that at? Where is our unused variable X at? Does it say XY? X comma Space, where's that at? Oh, here. Oh, wait, it looks used to me. What are they talking about? Unused. This isn't the one. This is the one. Here we go. Okay. So what I wanted to do is the toy model that we created in Rust. That's an artificial intelligence, that's a deep learning model. This is overkill. You don't need to use AI for this, but it is a sort of a toy model like we were describing. You can have it learn what an even number is and what an odd number is, and you can teach it just on like the first 100 numbers, and then you can give it bigger numbers in the future, numbers that it's never seen, and it will be able to predict those numbers. That's kind of like the whole point of AI. Rust is like a strict teacher. It really is, isn't it, MD? It's a strict teacher because the compiler is really gonna it's gonna let you know if you did something wrong, even if it's like not like completely there. Hey, Shrujan. Hey, Shrujan, good to see you. Welcome back to the stream. We're gonna wrap up our machine learning that we were doing on Friday with Rust, and it's we over the weekend I did a little bit of adjusting, and guess what? I remembered, it's been a while, but I remembered one of the most important things that you need to know for machine learning and artificial intelligence. You got to know this one really important thing. And if you have this one really important thing and you remember it going forward, it's kind of like a really solid foundation. Hey there. Hey, new here. Excellent. Good to see you. Vaibhav. Let me see if I can get your name. I want to make sure that your name is pronounced properly. Let's go ahead and see if we can get that really quick here. Let's see if we can get that. Translate. 1 second. All right. Let's zoom and then detect. All right. Okay. Let's see. Is this correct?
Vaibhav.
Vaibhav? Is that how you say your name? Vaibhav? Vaibhav. Excellent. Shrujan, let's cook some math. Yeah, we're gonna cook some math. We're gonna cook today with Rust, and we're gonna make artificial intelligence do the things that we want it to do. And the best way to learn is to get some toy models. Here we go. So we got a toy model here. This toy model does what is it called? Odd and even. It can find odd and even numbers. And I actually had it running here. Vibe on, sure. Okay. All right. So it's not quite that. Understandable. Noob Castro 231. Yep. Okay, cool. Good to hear. All right. Check this out, guys. Check this out. Here we go. So what I had it do was I had it go beyond, see here, check this out. So we train it. Hey, Alfie. Hey, what's up, my rusty fella? How's it going? We're doing good here. We're going to wrap up the artificial intelligence project that we were doing on Friday. And Friday, we were working on a deep learning model that we have that's just pure Rust deep learning model. So it works really simple models. So it's a toy model that helps you learn how AI works, really. And so we walked through about that a few days prior. And now we're actually using them. We're using the framework. It's like a small framework. It's really smart. The Pink Prayer Closet Podcast. That's a great name. Are you the guy who created the app Creator AI? That's a really good question. That's not me. That's someone else. You got me confused with a different person. Creator AI. I don't know who created that, but it wasn't me. Alfie, phenomenal. Can't wait. Yeah, I'm looking forward to this. Vaibhav, what are you doing here? Rust library or DL? Oh, for DL, this is basically pure from scratch. So let's look at this. So we have, I can open up some of these files. Basically, all the source code you see here is right here. It's completely here. We do have one dependency that we brought in, and that's called ND array. The ND array. It's similar to NumPy in Python. And it gives you just some nice pre-built math. So we're doing that, if that makes sense. Do you create ChatGPT, Steven? No, that's not me. What other AI do you create? Bro, you literally live in my fantasy IDKY. I feel a deep traction towards Rust. Isn't Rust great? I love it. No, and never had it for C++, Python, or anything else. Yeah, Rust brings this it's like this excitement. It reignites that. If you got into computer science before and you had an excitement, your entry into software engineering, that excitement gets reignited with Rust. It's really cool. It's very interesting that it does that because I guess part of it is there's a challenge to it, right? It's challenging. It's a challenging language, and it's worth it at the end because you get extra benefits. I'm a doctor. How to learn these? Oh, good question. So as a doctor, I guess what kind of doctor depends. You want to, it's just really simple learning programming languages. You just start with math strings and then, for loops and you're good to go. And like if statements. Alfie Stephen invented the computer. See, I can see where the theme of today is going. I can definitely give a sense we have. Absolutely. Celius, Rust is the best programming language. It is. It really is. Here's why it's the best programming language, because we are actively replacing all of our code at PubNub with Rust. And that is because it is so powerful. It's the language and your ability to iterate and add new features ruthlessly without having fear of degrading the software, because it does a lot of compile time checks that no other language pretty much in the world does as well. Rust is number one. Rust is the best programming language. You're an orthopedic surgeon, so that sounds like you work with your hands a lot, which, as a software engineer, you also work with your hands a lot with a keyboard. So you're on track. You got a good starting point. All you have to do, I would recommend starting with Python, the Python programming language. And you could probably even do this yourself. You just go Python in your development environment. You probably have it just open up a terminal window and type the word Python, like this, Python. And then you can say 1 + 1. And see, there you go. You just have the computer do something for you, right? You can then you can say hello, and then you can do, you say plus and then space plus with some quotes. And then you can do another space and you say world, like that. And then you see, you created a string and you just concatenation. This is called string concatenation. And you're off to programming. Let's learn some of the basics and you're good to go. Bro, this language is the theme, the color. Oh, yeah. Let's see here. The code editor, fonts, colors, concept AI, definitely my dream in a nutshell. Isn't it? It's so cool. I love it. It's very satisfying. I spent, I got a new setup here and I spent over the weekend getting everything set up for today, just for you guys, getting things going. How do you start studying these from scratch? The best is, I recommend at least the simplest language. Start with the simplest language because it teaches you the important concepts that are native to every language. And those concepts are simple things like simple math, flow control, like for loops and if statements to check if values, what the current value data is, and if their range of data, and that's like the core of every programming language. Once you get that, then everything else is just an add-on from that point. What does PubNub do, sir? Let's do it. Let's check it out. Let's check out what PubNub does. Here we go. So PubNub is I call it a communication API. So we're for software engineers, for developers, we have SDKs in every language, and you can connect any language to any other language on any platform on any device on the planet. No matter what the IP address is or what network you're on, you can enable communication with PubNub. And we have over 1 billion connected devices. You connect to our closest data center. Our data centers are across all of Amazon's availability zones. Once you have the SDK installed, say like on your phone or in an app, it'll connect up to the closest region. And then you can send messages to your phone in apps called in-app messaging. The top 10 apps in the App Store today all have built-in communication. That's what we provide. That's what we power. So you just use our SDKs and you can do things like send and receive. So you can send a message via publish. So you say pubnub.publish and you can send any kind of message you want, and then use a channel to define so I'll zoom in here. So use a channel to define where that data is going to go. And then you have a subscriber listening to that channel. And that subscriber can be anywhere in the world, on any device, on any platform, in any language. Isn't that cool? Yeah, so you want to learn. So that's a quick overview of PubNub. Let's see. Where to learn Python? Good question. YouTube. You know what? Actually, one of my favorite places to learn programming is where I learn programming is YouTube. Google like Hello World tutorials on YouTube. Hello World Python tutorials, videos, YouTube, and then there you go. And then you'll have some good starting points here. See, here's a 2 minute and 47 second video that should get you started. But there's also a 1 hour long video, which is that's a little bit long for beginners, I would say. You use Tmux. I use Screen, GNU Screen. It's called GNU Screen or GNU Screen. Let's build a PyTorch TensorFlow custom library in Rust from scratch. Yeah, you could totally do that. Let's take over the C++ monopoly. You can. Thank you for the likes, you guys. Appreciate it. If you can do that. So there are some projects that have gotten started. There's even libtorch, if you're familiar with PyTorch. Libtorch is a C++ library that PyTorch uses, and you can easily import that into any language, not just Python. And so you can also do that in Rust. It makes it easy for you to get started using some GPU acceleration using PyTorch, and you can build. It doesn't matter what hardware you have, PyTorch abstracts that away from you. So things, even if you have an NVIDIA or an AMD or Apple Silicon or some other tensor processing unit like a TPU in Google, you can do it using PyTorch or libtorch. And you can even do it in Rust, you guys. You can do it in Rust. It's really cool. That actually might be something that that's a good idea. We should write that one down. We should do that one. Let me write that down as ideas. Here we go. Let's go into general chat. All right. So ideas for future streams. Here we go. Ideas for future streams. Here we go. Streams here. Let me pull that over. So we do have a Discord here as well. I'll paste you guys the link for the Discord. Ideas for future stream. We can do libtorch plus Rust. Here we go. That's another one. There we go. Excellent. All right, let's get you guys the link to. Thank you for the likes, you guys. I appreciate it. We'll copy here. Let's see. Copy. Hidden. Use the copy button. Okay. Here we go. Pasting it in the chat. I'll paste that for you guys. There we go. Is it actually pasted? Paste. It's not pasting. Here we go. Paste. Is it actually going to paste? All right. There it goes. Paste. Perfect. Hey, you're live again. Yeah, Christopher. Hey, it's good to see you. We're live again. We're finishing up our Rust project for deep learning, custom written from scratch, deep learning framework. And we're going to wrap that up. We have one goal for the stream. I want to make sure to complete this goal is to teach you guys one important thing that you always need to know for no matter what framework you're using, no matter what framework you have in your hands, there's a very important critical item that everyone needs to know when you're building AI applications, and it is universal. And I'm really excited to tell you guys about it. It's really simple. I'm hyping it up. You are awesome, bro. Can we be friends? Absolutely. You guys here, join me on the Discord, and we can connect. We can be friends on Discord. Are you working here? I'm catching up with some of the chats, you guys. Guy with glasses, are you working at any big tech companies? Yeah, I'm working at PubNub. This is, it's kind of surprising. You already used PubNub and you never even noticed. You've already used PubNub. You didn't know that you used it. If you do any order delivery, like an app to get food delivered, or any order packaging, anything you see an item on a map moving around like a car moving towards you, or you're in a chat experience in an app, that's very likely us. That we're powering that technology, the chat experience. Do you have a LinkedIn? Yes, absolutely. Go Stephen LB LinkedIn. Here we go. Let's see. Let's see. Stephen. Here we go. Wait, I got to spell it right. LB. There we go. This is it right here. LinkedIn. I'll paste that in the chat as well, you guys, so you can have that as well. Ashford, welcome back. It's good to have you here. I'm going to paste that. There we go. Click the button. There's the LinkedIn for you. Let me see if I missed any of the chats, you guys. Now I'm a subscriber. Can we be friends? Are you on Telegram? Really want to connect with you. Yeah, definitely connect on Discord. We can also connect on LinkedIn. Ashward, hey, good to see you. Let me see if can we open source your NeoVim configs? Yeah, I just updated them this weekend. So it's better. It's definitely better. What we can do is, here, check this out. And it is regular Vim. It's not NeoVim, it's regular Vim. I guess I'm old school from that fashion because I like to use the software that's already pre-installed on most systems. And so NeoVim, yeah, you can easily install it. I know it's really easy to get started with NeoVim. Are you working at PubNub like for 10 years? Yeah, it is. You got it. It's been a long journey, and we've done amazing things, you guys. We were even on stage, with there's just so many amazing things over the years that is a lot of fun. We've been on main stages, so it's been a lot of exciting things. And yeah, the news you use default Vim too. All right, cool. Yeah, I love default Vim. Let's see, vimrc. Here's my vimrc. I can easily make this a open source option here. You know what, you guys? I'll paste this into Discord here. I'll paste this into Discord, so that way you can have it. Then that way, then we can open source it in a different way. So what we can do is, I do believe there is we can use triple. There we go. This is Vim. Here we go. I wonder, can we say Vim like that? Yeah, look at that. Check it out. Boom. Oh, wait. Here, let me click the send button. There's got to be here we go. Send. Actually, send. No, send for real. There we go. Here you go, you guys. This is my Vim RC file. So can we connect on LinkedIn? I just have to send you the connection request. Excellent. Yeah, I will. Sachin, what's your I'll try to find you. If that's your real name, I can find you on LinkedIn. Bro, you're literally the CTO of PubNub Instant. Yeah, that's it. That's me. You found it. You figured it out. Good job, you guys. Yeah. Oh, no, Owen, I missed your chat. Hey, it's good to see you. Glad you're here. Thank you for subscribing and joining the channel. I saw that you've joined, and it's really cool. It makes me happy. When I saw that, I got really excited. Sas D, hey, I'm new to Linux and software development, currently on Ubuntu. I want to be productive, recommending good steps. Okay, so if you join, actually, you know what? Someone, gave a really good. All right, here. This is who is this? Really quick, check this, guys. Here we go. This is this person who F ... whoever, I forgot what their name was, but they posted a really good list of recommendations for getting started programming, and it's a really good resource. A lot of resources here, and I definitely recommend Python if you're going to get started programming and you haven't done so yet. You want to start with Python. Python is the one to do. Why? Because it's simple, it's clean, it's easy to understand. There's no fancy symbols. There's few fancy symbols. You don't need to use them, and it just makes it really easy. So I really like that. If you want to start with Python, I can't join Discord. It says invalid invite code. Can you send again? Yes. Here we go. Let's do the right invite code. Let me do that again for y'all. Edit invite link maybe. Generate new. All right. Let's see. Let me say no limit, and then we'll say never expire. Generate. It says use copy button. All right, so I copied it. Here we go. We're gonna paste it in, you guys. Pasting it in, and boom, there you go. New Discord link. That should do the trick for you. That should work for you. Let me know if that works. It should work this time. Hey, the journey of PubNub started. It did. Yeah. We've one time at some point in one of the streams, we will need to go through and give you guys an overview of how everything happened, all the things. I'm going to share mine too. Everyone here, please share your too. Yes, please do. MD, share your Vim RC file, so that way we can all sort of see any of the really cool things that we've got, and we can add them to our own Vim RC. I need some advice. I'm starting an AI. You're starting as an AI engineer, Vibov, an AI. Okay, so I've got you. The best here. Let's do it. Okay, you guys, you are at the right point in the stream. If you're here right now and you're on the stream and you're in the live, you're at a really pivotal moment. Excalidraw. How do we? Here we go. Excalidraw. All right. We are going to give you the best tip that I think is the most critical tip for software engineering when you're building artificial intelligence. And this goes for machine learning, deep learning, and AI development. And you might already know this. This is like very basic, but it's something that you always need to keep in mind, because it's why all the algorithms are the way they are. It's like the foundational reason. All right, check this out. All right, let's see if we can draw this. Just use arc with DWM minimal with power. Yeah, there you go. Work at Siemens. Oh, there you go. Okay, so you've got that's actually really cool. How do we architect this project? Do you use any design patterns? I am currently creating my project in Go. Oh, Golang. Yeah, Golang is a great language, and using clean architecture. Be careful with the idea of clean architecture. Definitely means simple architecture. You don't want to do. You can build heavy abstractions and feel really good about it. But what you're doing is actually creating a complex system that might be challenging to maintain in the future. I'm thinking of it as kind of overkill. Yet you can over architect and over engineer a project really easily and really quickly, and have 90% of your code actually be the framework itself and not have any values or benefits. I'll use Excalibur to explain anything to an interviewer. That's really cool. Yeah, so that's like the plan. Do you enjoy Python? Python is a very enjoyable language because it's so simple and clean and easy, and it's easy to read. The challenge is, at least something like at PubNub, for example, we have so many connected devices that we cannot use Python in a production environment anymore because we have trillions of transactions, trillions of JSON payloads go through our network every month. And we have to use Rust or C for that. Python is just not fast enough for us, even if we use underlying libraries that are written in C or Rust. Python, that exchange in the data is just not fast enough. So we have to use C or Rust. And so we're currently migrating everything to Rust as much as possible. Agreed? Excellent. Yeah, that's here. You do miss the curly brackets? Yeah. So there are some nice things, but with the curly braces. All right, here we go, you guys. All right, let's see. We need to do that. All right. Critical AI and ML. This is like, you need to know this. Need to know. All right, this is what you need to know. If this is a critical item. When you are importing data, so let's say you've got some data. This is the input data, right? Input, and the data is like, say, a string, hello. Or let's say we've got a different kind of input, and the input is like a number. Check this out. Or input is like a number, like 2025. Yeah, like the year 2025, for example. So these are two different kind of inputs, and then you have an AI model. Let's see here. See, here's the model. We'll say this is the model, the AI model, and that really is just a bunch of numbers, right? It's a matrix, like a multi-dimensional array, right? Like a 2 by 10 by like 2 or something like that, right? Multi-dimensional array. You can do that. So that's basically what the AI model is. And there's just a bunch of numbers, right? It's just a whole bunch of numbers. That's really all it is. But there's actually an important value to these numbers, I got to tell you. Do you use Actix? Actix is a great Rust server framework that allows you to write your code. It's for building a REST API server using concurrency, and the framework takes care of most of that for you. So what we've done is Sachin. That's a really good recommendation, is Actix. It's one of the most long-lived Rust server framework for building REST APIs. Actix, right? We use Axum and Pingora at PubNub. So let me just type that. We use at PubNub. I'll just type that into our Discord. At PubNub, we use Axum and Pingora. These are two different Rust server frameworks. Pingora is written by Cloudflare, and it is sort of like the replacement of Nginx, which is written in C, and it is for routing data to different endpoints. And Axum is, I would say, kind of like an iteration, the next step over Actix. It is newer than Actix, but it is stable enough that we use it in production. So those are the Rust frameworks that we use at PubNub. If you guys were interested, one of my friends there in I don't know what that is. I am here at Picked Poon. Oh, okay. Excellent. I don't exactly know what you mean by that. Yeah. All right. So here's actually, this is cool. This is MD's RC file here on the screen. We can zoom in a little bit. I'm actually just kind of curious to take a peek at that. Let's take a peek at your MD file. Let me see if I can. Here we go. All right. Wow, you've got a lot of stuff set in here. Or tab stuff's 4. Excellent. Very nice. Yep. Indent, file type. Okay. Xterm 2. Okay. There's a lot of interesting. Oh, sweet. Yeah, you've got a lot of undo levels. You've got 10,000 undo levels. Wait. How many undo levels did I have? How many undo levels? I only had 800. I only had 800 undo levels. It might be worth it to have 10,000 undo levels. That's really awesome. That's really awesome, MD. Okay. Undo directory. Okay, cool. So you keep that. HLS. You definitely want HLS. That's a good one. Wait, highlight matches as iType. I haven't used this one before. Ink search. I've used HL search, but not ink search. Highlight matches as iType. That kind of is interesting. I want to try that out at some point. These are some good ones. So you've got a split right. Okay, so you've got a split below, and then you've got vertical. Yep. Okay, so last status string. Okay, and then you've got a special status that you've got set up here. Some status lines. Neat. MD, this is cool. You've got an excellent RC file. This is a great Vim RC. Very nice. Yeah, and I also have a PB because I'm on a Mac, so I map a keyboard so that way I can copy and paste. So I can use visual mode, and then I can copy and paste to my actual OS's clipboard buffer, which lets you really easy just on your keyboard copy and paste, and then you never have to use your mouse. It's like you don't have to like highlight text like I'm doing that right now. All right, jumping back to the critical. You guys, the critical AI and ML need to know thing. For every AI model, for all of them, you have to have this one thing. This is like a really critical item. It's huge. You always have to, I'll just jump right to it. The numbers always have to be basically, you want to keep the numbers between -1 and +1. You want to keep them in that range. You don't want them to go too big. You don't want like 2, 3, 4, 5, or 10. Like now you're getting a little too crazy. And then once you get above 10, now you're out of the picture. You can't do it. So the idea is constraints. It's all about constraints. So you want to constrain. The idea is you need to constrain your ranges, numeric ranges between -1 and +1, 1.0. You basically want to do this as much as possible. There's some leeway here. There is some leeway. You can go up to like 2 or 3 and you'll be fine. But all numbers, all of it. So that means that the input, the matrix, the output, right? The model, everything has to be constrained to output. Yeah. So even the output all needs to be between 0 and 1. And you can do that pretty easily. You just want to make sure that you do that. And that was actually a really critical item. So that makes it challenging. And that's what defines all the math behind this, right? All the math that you got. Let's see. We've got some other languages here than chat that I'm not familiar with. I'll let you guys figure that out. Thank you for the likes, you guys. Appreciate it. Definitely. So here's the important numeric constraints. Everything. And that goes for all of these things. So not just, so I think I can press 5 here. Oop, no, hold on. Undo. Yes, go back. 5. Yes. Here we go. It goes for this, and it goes for this, and it kind of goes for this, but you don't necessarily, you kind of want it there too. And for this too, right? So 5, here we go. And for this. Everything needs to be between -1 and +1. It's definitely some spam in there. We got some spam going. We need some moderators moderating the channel here. Let's see. Add as moderate. So manage moderate, standard moderate. Here we go. There you go. All right. So I'm going to add some of y'all as a moderator. 1 second. Let's see. We got there. Let's see. And then feel free to, if you see any spam in the chat, if you see any of the spam, feel free to get rid of it. Let's see here. Let me see if there's, let me know if anyone wants to be a moderator. Just shout it out if you are happy to be a moderator, and then I'll click the button and you'll be a moderator at that point. Let me know, and that'll happen. All right, so here's the jumping back here to the critical item. You want everything, all your numbers to be between -1 and +1 as best as you can, right? You can go -2 to +2. That's what you do. 1, 2, 3, zoo wild. What flowchart is that? This is called Excalidraw, and it is an easy way to sort of represent data or ideas pretty quickly. I like it because it's kind of got like this little bit of organic touch to it. So you can see like the circles and everything. They all look a little bit different, and it kind of feels more natural. So it's called Excalidraw. Excalidraw. Yep, there you go. Yep, that's the one. Excalidraw. Yeah, Excalidraw. Exactly. So click the buttons, and there you go. Is that BIM? Ashford, me. You guys. Okay, here we go. I'm going to add you guys. Everyone who said I'm going to add you. 1 second. Me, here we go. Adding as moderator. Here you go. All right. Ashford, moderator. MD, you are adding as moderator. Moderator. You get a moderator. You guys get a moderator. There you go. There you guys go. If I missed you, let me know. The biggest challenge is solo dev is focusing on consistency. How do you do it, especially when you are not feeling it? Yeah, so actually you bring up a really good point, because there's often times in your life where you don't have that motivation and you just don't feel it. But there's also times when you're just like really motivated and you're like, man, let's go do it. We can make it happen. It's going to happen today. And you sit down and you're like, and you type it out and it's all great. But maintaining that motivation is challenging. Really, the hard part, I would say, is just keeping your focus on something really tiny and small. Say you're just going to do this one thing, right? For example, this one stream, we've got like an hour here or so for the stream that I'm going to dedicate time to. And then, but I have one goal. That's just one goal, and is basically to teach you guys this one critical item here. I wanted to make sure that you guys know this. And then there's a bonus item if we can get it. I want to show, actually I kind of want, because I put it in the title of the stream, is Threeven and Throdd. I put it in the it's called Threeven and Throdd. So Threeven and Throdd, Throdd. This is let's see here, AI mode. Let's do AI mode. So Threeven and Throdd, go there. This is invented terms used to mathematical circles and online communities described as numbers based on their divisibility by 3. And so it's kind of like an even odd, but then you can go a step further and go Threeven and Throdd, which is divisible by 3, or you go divisible by 2, and the even and odd. So it kind of looks like this, if that makes sense. And I wanted to teach an AI. I want to teach an AI that. So Vim is that the Vim idle little bro? Yes, it is. We are using Vim here. This is definitely Vim. The biggest challenge, yep, absolutely. So I hope that describes some details you on the challenge. Just focus on something small. Like if you're not feeling it today, if you're not feeling it, which often, like sometimes I don't feel it someday, but you really have to get something done. Just choose one thing, just one thing. It really small, little teeny tiny thing, and you're good to go. And then just that'll be your one thing for the day. And then if you feel good afterward, and you probably will, then you might be motivated to do another one thing, right? You might be able to do one more thing after that. Thanks. So be a good moderator. Excellent, MD. Thank you. Stephen, please, can you explain something more about ML Ops? My project is going, thank you for the likes, you guys. Appreciate it. My project is going to prod in a week, ML Ops. So it really depends. Do you have training data? So when you vectorize your data or you create embeddings, you don't want to recalculate that every time. So you want to store that information somewhere. How are you training your model? Does the data, how do you access the data? I guess do you train it on portions of data, or do you use the entire data set? So that's a big part. And then you have the weights themselves. Where do you store the weights? Probably in a flat file, right? In a flat file. And it probably depends if you're using PyTorch. There's a module for PyTorch that you can export a single file, and then you can just read that in. And then you will probably load that into a container that you can run in many of the orchestration systems that exist today. Kubernetes, right? You could do Kubernetes across GPU servers. You could do other kinds of containers. There's a lot of options there. And do you have auto scaling, right? You could do that as well. You can bake that in. There's a lot to ML Ops. That kind of, if you're interested, we can speak a little bit more about it if you give me more context about what your project is and kind of what more of the areas that you're considering. But it really comes down to data, the model itself, and then scaling, and then ways to scale based on like utilization of the hardware. I think that's the biggest aspect of it. Yeah, thank you for the likes, you guys. Appreciate it. This is really cool. All right, so just gonna wrap up here this idea. Critical is to keep all items in range between -1 and +1. You want to do that because this is the whole point of all the math. All the math right here is because of these numbers. These numbers, this is critical. You need it to be these numbers. Input, output, and the matrix itself, the weights. So when you have like an input of hello, you need to do something called vectorizing or embedding, which is like a fancier vectorization, and it converts it into numbers. And so you want to convert it into an array of numbers between -1 and +1. And that's what that is. So you can take these numbers, like say you want to do you can do token based, like large language models. They do word based tokenization. So hello is a single word, but you throw it into an embedding model, which gives you back an array of like, say, 512 numbers, which is a lot of numbers for a single word, right? And that's not even the big one. The big ones go up to like 4,000. What is it? 1024, 2048, and 4096. You can get 4,096 floating point numbers that represent this one word right here. You could, like, this is that's word embedding. And it's that way because it represents the meaning and context of the word that can be used in conjunction with other words. So it's really powerful. But you can go even smaller. You don't have to do that. You can do letter based, right? So HELLO, you can just use this as you can get the ASCII value of those words, and then you can convert the ASCII value, because the ASCII value is still above 1, and then you can either what do you call it? You can embed it with binary encoding, or you can do it based on a range. So you can say the value of the range is between, like, because of 26 letters in the English alphabet, you can say dividing H over 26. So you can divide it by 26, something like this. So you can H divided by 26 will equal a fraction, its position in the alphabet. Like, that's kind of like an idea, right? So what actually let's do, let's see, A, B, C, D, E, F, G, H, right? So that's 7. It will be 7 essentially in that case. But you'll have to offset it by, 20. What is this? Sachin, what is that? What did you do? You showed something on the screen. I don't know what that is. I've never seen that before. Hold on. What is happening here? I'm actually super curious. You got it. Let me know, you guys. What is that? What happened just now? It shows a number on the screen, and I appreciate it a lot. I think it means money. I'm pretty sure that means, like, it's a gratuity of some sort. Thank you so much, Sachin. That is so huge. That is amazing. Wow. Thank you. I appreciate it a lot. Let me know in chat. What is that? Thanks, man. Thank you for your enthusiasm and made your day. Oh, that's so great. I'm so happy. That makes me happy that, I think he donated to you. Yeah, that's Christopher. Yeah. Wow. Thank you, Sachin. I appreciate that so much. You've made my day. You know, I'm talking about making your day. You made my day. I appreciate it. That is so much. I'm very humbled. I appreciate it. We love talking about all the technologies, more of an agentic RAG system. Okay, so you've got your embedding model is about 0.6 billion parameters, and that has to be used to vectorize your queries at a very large scale. I'm exposing the model as a REST API service. Okay, so you've got an embedding model, and your embedding model is 0.6 billion, which is 600 million floating point numbers. And what is your that's actually a good size, because you can run that on a laptop pretty easily. And so I guess it depends. So you want to load that in memory into a container, and then you want to restify that. You're exposing the model as a REST API service. You want to suggest about having some embedding model perform well at scale and able to handle concurrent load efficiently. So you have a lot of choices. The model's small enough to work pretty well in on CPU. So what you can do is you can just create a whole bunch of instances or copies of that in a container, and then just duplicate them easily across a server fleet with a whole bunch of CPUs. That's one way to do it. The other way is to use GPUs, which you totally can, but GPUs don't scale quickly, and it takes time to transfer the memory over. So there's just like a little bit of latency on spin up. A little bit of spin up. Hot Frost Music Archive, how's it going? What model are you using, Love, for your captions? Are my captions still going? Test, echo. It says music right now. 1 second. Oh, it's good. Okay, it's good to go. I've got a new setup here. Why does it? Okay, cool. Live captions. So I wrote this software a while ago. It's called OBS live stream captions, subtitles, titles, GitHub, Steam LB. I think this is it. Let's see if we got it. Is this it? Yes, here we go. See, look, the AI overview has the answer. This is it right here, you guys. Check this out. You see here on the screen, we have some subtitles, and they are very active on the screen right now. They are from this GitHub repository, which is my GitHub repository. Check it out, you guys. Provides a solution for adding live stream captions to OBS. And it works for Twitch, but also, as you can see right now, we're streaming on YouTube, and it works on YouTube too, just fine. It works on YouTube fine. So the functionality involves a browser source in OBS Studio that overlays the captions you see here, and repository provides a web-based interface that generates the display captions, which then is integrated through, and then it uses PubNub through this dashboard here. And it makes it's a seamless way to add captions. Thanks for sharing. I'll check out your repo. Oh, cool. Yeah, absolutely. Thank you. I appreciate it. Yeah, Steven, Twitch, OBS subtitles. We'll go to it really quick here. Boop, 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 click the button, and where does it go over here? I think. Okay. Here's the actual repository. We'll zoom in. This is it right here, you guys. Twitch and YouTube subtitles. Add subtitles to your streams. It's a really simple guide. You can click some buttons. It's like a 1, 2, 3. It's really easy. 1, 2, 3. Really easy. Hey, another day. What project is that? Jambuster. Hey, another day. What project? Hey, thank you for the likes, you guys. What another day? Which day? Jambuster. Quick question for you. What day are you describing? Which one are you describing? I'm actually kind of curious about that. Which one? What day? There's multiple days. But you know what we do? Let's see. Check my time here. Okay, we do have some time left for the stream. We got a little bit more time left. So let's go back here. I wanted to wrap up this most critical item for AI and machine learning is you want to keep all your numbers between -1 and +1. That's really important because when you expand your numbers too far, that makes the model not good. It makes it not happy no matter what the scenario is. I'm sure there are a lot of scenarios and situations like ReLU that allow you to grow your numbers inside the model, but when you're doing input and output, you want to make sure at least you want to always try to keep between -1 and +1, even for your inputs. And so, for example, say you have this number 2025, right? You got this number 2025 here. That's a big number. That's 2025, right? Even 5 is too big, but 2000 is huge. And so what you want to do is you want to convert that. You want to vectorize that. You could do embedding, but it's probably better just to do a vectorization. And then you can do that by doing a binary encoding. This is one of my favorite ways. If you're just doing numbers and you're just looking at numbers, you can do binary encoding. And it kind of looks like this, right? So you take that and it goes 2025 becomes ones and zeros, basically, an array of ones and zeros. So a bunch of ones and zeros like this. And we'll find what the actual number is of that. I can show you how to get the actual number, right? So which project are you working on right now? Oh, Jambuster. Okay. So we're wrapping up from Friday's stream. We're doing, we're even and odd deep learning detect. So the AI will be able to learn to recognize even and odd numbers. And we're only going to train it on numbers between 0 and 100. It's only going to know about 0 to 100. But we're going to ask it, what is 200, right? What is 300? It's going to know. It'll know if the number is even or odd. What is 4,000? Will it know? It probably will. And that's like the whole point of training AI models is you have the chance to train on a small set of data, and then you present the model with future data that it's never seen before. It's never seen it, and it will be able to get the answer right. And so Jambuster, that's what we're working on. We're just before. Oh, thank you for the likes. Appreciate it. Once we get that going, actually, really quick, I want to get my calculator open here, and you go. And on a Mac, you can go calculator. Let's see here. And then I think you can press Command 3. Here we go. Yeah, look at that. Check this out, you guys. It might be hard to see on your screen. You know what? I'm going to enable the zoom feature here. Okay, that's good. Absolute. Yeah, good and absolute. Yes. So let's see. Let's go type in 2025. And you can see here, the binary value is 101. Let me see if I can, I'll type that in here into our screen so I can see that really quick. Click. So 2025 actually, and this is real. This is a real binary value, guys. 10001. There we go. And then it goes 0, and then I got 1, and then a whole bunch of zeros. All right, here we go. Let me bring that up real quick. A bunch of zeros here. Click on it. Click copy, paste. Okay, a whole bunch of zeros, and then a 1 at the 15. Okay, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8. All right. 1, 2, 3, 4, 5, 6, 7, 8, and then 1. There we go. So that's what the binary value, and then we vectorize it. This, I think, is also called one-hot encoding. one-hot encoding. I do believe that's what this is called. You convert your number or your value or your input data, whether it's an image where you're doing an image like a photograph of a kitty cat, or a video file like you video the sky or a tree, and or it's a number, right? Like the number 2020, like the year 2025, and it looks like this. You need to vectorize it in a way or embed it, and that's what the number looks like. So this is converting the numbers into, right, between. You can also do something like this. You can go -1 and just replace all these with -1s as well. That works too, because you're staying within the rule. Oh, not two, -1. There you go. You can do that as well. So you can do between, which that works too. And it's all, these are kind of like hyper tuning. But I think this is harder to read, right? It's harder to tell. Like I can't see the numbers so well. I like it better when it looks like this. Like when it's a bunch of zeros like that. I think this is easier to read. So I like that better. So this is like one hot encoding. And so this is your input data. And that goes into the model. And then the matrix itself, you want to make sure that all its numbers stay between -1 and 0. Thank you for the likes, you guys. And when you do that, and all the numbers stay in between -1 and +1, you do that using math. And so activation functions help you along the way. So things like sigmoid, tanh, and you can do other kinds of, but those are common. RelU is a little bit different. RelU does allow the numbers to grow a lot, but it's it's less computationally intensive, and because it doesn't use it doesn't use multiplication. It uses actually, I'll show you guys really quick. Let's look at RelU. Okay, here we go. We're gonna jump into source. I think it's called activations. Here we go. And here's RelU. We're looking at RelU now. Let's go. There we go. So here's RelU. This is where it looks right here. Look on the screen. This is RelU. Right here, you guys. Check this out. It looks different. Look, it looks different than, say, these other numbers here. All right, so check. Let's look at a tanh, for example. Or actually, sigmoid might be. See, we've got multiplication, essentially, exponents, right? Powers of. And you compare that to the forward on this, which is basically just a flow control, right? If you look at it, you see no math operations here. There's no math operations in RelU. It just checks to see if the number is greater than 0. And if it is, it returns the same number. If it's not, then it flattens it to 0. So basically keeps it low. And then the same backwards when you're doing back propagation, except for it's sort of like the other way around, right? It returns 1, else 0. Oh, neat. Oh. That's actually a pretty good distinction. When you're doing back propagation, that's really Sage Gaming. Hey, how's it going? It's good to see you. Happy to have you here. We're currently walking through the AI that we built last week. We're going to make sure to wrap it up this week, and we walk through the most critical items when you're training AI models is to make sure that all your numbers are between -1 and +1. If they're too big, then your model will have a very hard time learning or functioning at all. So all the numbers, every number has to be between -1 and +1 everywhere in all spots. The best you can do. So it should be -1 here, -1, +1 here, and it needs to be -1 here as well, and over here. And so you saw here is the input number, like say 2025. That is a very big number. It's too big for the AI model. You can vectorize it by doing binary encoding, and you can do it like this. So you've basically turned it into an array of 1s and 0s. So I think it's called one-hot encoding in this case. Or it's a binary encoding. And so it's a way to do that. You can also do letter-based encoding with like a string. So like H is equals to set. It's like, it's not, H is 7. H is equals to 7. So let's see here. H equals 7 in this case, because it's the 7th position in the alphabet. So then that would be 7 over 26. And that's going to be a number between 1. It's definitely going to be a number between 1 and 0. And so 7 to 26. What is that? It's some floating point number. Calculator. 7 divided by 26 equals let's see here. Let's go back. 7 divided by 26 is, it's going to be this number here. Here we go. So that brings you into, so you can do that as well. That's another way. That's another approach that you can use. So that's like a really critical item that you need to know when you're doing AI and machine learning. It's a critical item. Keep your numbers between 1 and 0. And if you just keep remembering that, then you'll kind of have an understanding of the foundation as you are setting up your models, your multiple layers, and your outputs and your inputs. then you'll be in the good spot. And if you forget it accidentally, then you hit a problem and you won't know why. You won't know why your model's not learning or why it's not performing correctly. It just won't be obvious. It just, you'll hit, it just won't work. But it won't fail. It won't crash. It'll still operate. It just won't be successful, right? So this is it. The one thing to take away of anything is this. Critical AI and ML need to know, constrain your numeric ranges between -1 and +1. And that's what embedding does. So we had an embedding model here, which in a RAG system. Your embedding model is 600 million parameters that is used to vectorize queries at a very large scale. So another thing is when you want ML ops consideration, if you want to do caching, you don't want to keep re-embedding the same thing over and over because the embedding process is pretty computationally expensive. So you can cache those inputs and you can store them. So you can take a sort of like a hash of the string or the input vector and then store it like in a database of some sort and use that as a key. So that way next time, before you actually process and re-embed the data, you can fetch the pre-embedded information and then just use that going forward. So that'll make it a lot easier from a compute perspective and it'll help you scale a lot, especially if you have a lot of the same kinds of inputs over and over and over. So let's go back to our code window here. So here this is what we're going to do. This will be the last thing that we do in stream today. This will be the last thing that we do in stream today. We will go through and get this to work. Let's see here. Let me double check. Let me double check something really quick. Hold on, you guys. I'm going to take a peek at something really here. 1 second. Looking at something on the screen here. Okay, cool. Looks good to me. All right. Happy about that. Okay. Just checking something. Just got to check on something. All right, here we go. All right. So vi source lib. I think that was it. Let me double check that we don't have anything else happening here. Okay. We can close that. We can be done with this. Oop, we don't want to do that. Let's get rid of that. Get over here. Just clean up some windows. Hey, Lambda, how's it going? Good to see you. Welcome back. We're finishing up our machine learning. We're finishing up the machine learning. Source lib. Here we go. We're wrapping it up. We got it working last week, and what we want to do is show you it actually working. So we taught the model even and odd. Check this out, you guys. This is really cool. So we grab our training data. So we build our model, and our model looks like this. It's a simple model with 3 layers, basically input layer, the hidden layer, the in the middle, and then an output layer. Well, sort of. There's actually 1, 2, 3, 4. There's 4 layers here. You can't really tell, but there's an output layer here, which represents this. It's a 1-dimensional output. The input is 8 dimensions because we're doing an 8-bit input. This is the 8-bit input. And then the invisible layers are 16 by 16 and 8 by 8 in terms of number of floating point numbers. So that's actually quite a lot, but not too many, right? It's not too many. So 8 times 16 is 128 parameters, right? That's the first one. And then we have 16 times 16. That's 256 parameters. And then we have 16 times 8, I think. 16 times 8, 128. And then another, say 8 times 8. There you go, 64. So it's only a couple thousand, right? Up to a couple thousand parameters. Not a lot, but it doesn't need to be a lot because this is a toy model. And then in a toy model, all you have to do is, it doesn't need to be very big. So here, this is what we did. So we built the model, we're training the model, and our input data is get our odd and even data. What we did here was we generated a number between 0 and 100, an array between 0 and 100, and then we're vectorizing it immediately into an 8-bit number, or 8-bit array. And so it's really simple. All we do is we take the bit shift, we take the number and shift it by the current bit, which is a number between 0 and 8, or the position of the bit. And then we AND it, and we check to see if it's equal to 1, else it's going to be equal to 0. And that is going to give us the training data. That tells us if it's odd or even, essentially. And so we generate this array of 8 length, and then that is used as the input data. So it looks like this. It kind of looks like this right here. So this is what it looks like. This is what the training data looks like. We'll show you guys here really quick. What's the training data look like? It kind of looks like this. Let's see, a bunch of numbers. Here we go, like this. It's actually quite a lot of numbers. So I'm just going to get rid of some of the decimals just to make things look easier. Looks like this, looks like this. 1 second, you guys. Hold on a second. 1 second. Got it. 1 second. Oh my God. Oh, just a second. Oh, here we go. Okay. My face was itchy. Edit, face itch. Here we go. Okay. So it kind of looks like this. This is what that looks like. And so we do that for every single number between 0 and 100. And so it kind of looks like this. There we go. There we go. That's kind of what the array looks like. Just about like this. Or so. And it depends on the number. So here you go, guys. Right here. If you can see it on the screen, this is what it looks like. It's basically an array. And that's what we're doing is we're generating this right here. Right here. And so then we create that for every number between 0 and 100. And then that is our training data. And then we have to generate the answers, right? So Christopher, hey, the captions while you did that were hilarious. Were they? I wasn't looking at the screen. I'll have to look back at the video. Yeah, my face was itchy, so I had to go off camera for a second. Shit my face. Oh, sorry, think about that. Yeah. So here's the training data. And so what we've done is we're detecting if it's an odd or even, and that's our training data shape. And then we have here, is it odd or even, right? So 0 to 100. And thank you for the likes, you guys. Appreciate it. Is it odd or even? And then now we have an array. And so that's actually a really small array, right? It's either going to look like that or it's going to look like this, odd or even, right? So it's a simple array like that. And so then we do that for all our numbers between 0 and 100 as well. So now we have all of our training data. We've got our input data, which is a number between 0 and 100, but it's encoded as bits, an 8-bit array. So each of the numbers look like this now. Because we want to make sure our numbers, you remember the numbers, they got to look like this. They can't be big numbers. They have to be little numbers between 1 and 0. And then that becomes our input and training data. So then we jump over here and then we train the model. And what that does is it jumps in. It asks the model for every single input, like number between 0 and 100. It'll ask, hey, what do you think this is? What do you think the answer is? Is it odd or even? And the model will give an answer, and the answer will be wrong. Initially, it will be wrong. Most likely, it'll be wrong. And so then we take how wrong it was, and then we subtract it by the actual answer. So say the model said it predicted the number 1, and it predicted that it said it was an odd number. It predicted it, but it said it was an odd number by about that much. It said it's most likely an odd number. And so it's wrong, but it's wrong by about this much. So here's how wrong it is. So you have to then create the delta. The delta equals, and then you say -1, right? 1, or you could do it in either direction. Doesn't matter. 1 minus this, which is going to equal about that. So this is how wrong it is. And that is the loss, essentially. How wrong is the model? And so you run it through for each of these numbers and you see how wrong it is. The model is wrong by this much. And then you multiply that by a learning rate, which is usually, a small number. And it and then it reduces, then this becomes a gradient, right? So then you can apply this in back propagation and you apply it to all of your matrices here, all of your matrices, which are these things up here. Where is it? Here. These things are just numbers, right? And so you apply that across the matrix, and then using a gradient descent, which just means you're going to apply back propagation of the deltas from how wrong it was, and then you've trained it a little bit at a time, and you do that in a loop. You loop it, and it just loops, and you keep doing that over and over and over until the model comes to some coherence, and it finally makes sense. And now what you've done is you've trained the AI model to recognize a negative number, an odd number or an even number. Isn't that cool? I think it's really cool. And so let's see here. Let's see. That's where the training comes in. So let's go ahead and hide this because that's a bunch of invalid syntax. Here we go. Then you train the model, and then you have it predict its output. So after you've trained it, then we're going to ask it the same question again, and it gets everything right. Cosmo Denny, hey, how's it going? Oh, damn, I've been looking forward to this one. What is the ideal outcome? The ideal outcome, thank you for the likes, you guys. The ideal outcome is it is able to predict a negative number, or sorry, a odd number or an even number without having ever been trained on it. Lorax, the best, 89. Hey, how's it going? Good to have you back. We're just wrapping up stream here. We are at the end. Yes, that's right. We're at the end, but we have to show you it actually working. So we're just walking through the code, and what we did was we trained the model, and then we predicted the output for every single element, and all the elements. Excellent. Hey, hi, good to see you. Happy to have you here. Welcome back. We're right at the end of the stream-ish, but we've got a few more minutes here. We've got a few more minutes before we go away. So check this out. So now we can test the model on numbers it's never seen before. Data that it's never been trained on. Isn't that cool? And so we re-vectorize that data using one hot encoding. Maynard, hey, did we get Discord up? Yeah, we did. We got Discord up. I love all these shorts. Look forward to them after work. Excellent. That's great to hear. We've got a lot of shorts. The AI is taking care of that for us. Here, we do have a Discord. Let me go ahead and get that link for you. Here we go. We're going to copy that. We're copying that link, and we're going to paste that over here into chat for you. So you've got our Discord link for you. And there we can also we can share ideas about what are some upcoming streams and things like that. What do we want to do? So yeah, we had a lot of joiners today in the Discord, so definitely join the Discord. You're welcome, Maynard. Lorax the best. I can confirm this. We are best friends. Excellent. That's so cool. That's awesome. Definitely best friends. Love it. That's so cool. All right, here we go, you guys. We're wrapping it up. We're at the end here. We got to the bottom of the file. So what we did here was we're testing it, so we know what the answers are already. So we have the test data and our predictions. So we use model.forward. So model.forward is the same as saying predict. It just says run your analysis on this set of numbers and tell me what you think the answers are. And it's going to predict all the numbers between 100 and 201. It's never seen those numbers before, and it's going to get everything accurate. It's going to get them 100% correct. Isn't that cool, you guys? Check that out. And so what we can do is we can then compare and evaluate. So that's all this is here. It's just comparing and evaluating what the model got right and what it got wrong. You want to see it run, you guys? You want to see what it looks like when this runs when it actually runs? Because we just finished the code review. Finally, after it was like 3 days of streams, here we go. I mean, AI, it can get complex, but you're really looking at the simple stuff here. All right, you guys, here we go. We're going to see what it looks like. We're going to rerun it here. Cargo run. Uh-oh. Hold on. I did some, I was messing around with things. Let's go ahead and get rid of all this stuff. We don't need any of that. Let's see there. All right. Did I mess it up? Oh, no. Okay, good. Okay, good. Here we go. All right. So the model's training. You can see the loss. It got really low, which means it's learning. We're good. All right. We did it. All right. Let's pop up to here. All right. The predictions. All right. So the input 0 is 0 an odd or an even number. Is 0 an odd or yes. How does PubNub work in order to deliver apps like Swiggy? Sachin, how do you know? How did you know? Yeah. We'll jump. Actually, we'll do a tangent on that real quick. We'll jump in. All right. So PubNub diagram maybe. I don't know if we have a diagram around here. How does PubNub work? Let's see. How does PubNub work? So we've got a diagram. I want to see if we have an actual diagram. Here we go. This actually looks pretty good. This is it's a little advanced. Wait, it's the diagram here? Okay, here we go. Let me see if I can zoom in on that. Open tab to new image. Here we go. So I'll zoom in for you guys. All right, so we've got PubNub here, which is the PubNub infrastructure that runs Rust and C on top of Kubernetes in Amazon's availability zones, all of Amazon's availability zones. The end users, like on a mobile app here, like on your phone, will connect up to the closest region that they are currently close to, and that will give them their active subscription. The developers will use an SDK to build a channel name that the app will listen to, and they will be able to send data and receive data. And PubNub is a broker. It's a message broker. It will be able to transmit data no matter where the targets are in the world. It will connect to your end users and deliver the message. If the device is offline, because it might be offline or it might be in your pocket, it will automatically reconnect, recover, and then download any messages that it missed. So that's how that works. And then apps like Swiggy, which show you where your delivery is on the map. You can see that's what's happening here. Your mobile app is subscribed to a channel, and then Swiggy driver is updating their coordinates on a map with their geolocation, and it's publishing that data. And then that data comes back as a message into your phone via lat long coordinates, and then you can see where the driver is on the map and how close they are to get an ETA of your delivery. I hope that gave you the answer that you were looking for, because it's a really similar to Kafka. It is like Kafka. You got it. It's very much like Kafka because it's got that store and forward capability for durability and message reliability. And if your device is offline, you can automatically recover messages. And it also is like topics based, right? Kafka has topics. Thank you for the likes, guys. It has topics. PubNub calls them channels. We call them channels at PubNub, but they're topics or channels. They're the same thing. It's just a name. It's a string that defines where messages are coming from or going to. That's all it is. It's exactly like Kafka. You can think of it like that. And what we've done is we've custom implemented this in C and Rust. And we've distributed this in containers orchestrated by Kubernetes running on Amazon's availability zones. And we do GeoDNS. GeoDNS, like domain name service, where your device will connect to the closest region and they will be able to publish, subscribe data between them. And so that's kind of how that works. Very much like Kafka. Got it? Cool. That's great to hear. Thank you for the likes. Appreciate it. That's awesome. I love it. All right, here, guys. We're wrapping it up here. All right, we're walking through the things. And then after this, there's one last thing I want to do and do Threeven and Throdd, which is the finale. The final thing we're going to do with this AI model is the Threeven and Throdd. The Threeven and Throdd. The subtitles will have a hard time with that because those aren't real words. They're not real words. The AI doesn't know them. It doesn't. Okay, here we go. So do you guys, here we go. Let's jump in. So I'm going to zoom in. 0, which is this one right here. This is 0. Is it odd or even? The model says it's even. All right. Yeah, it's even. Is 1 odd or even? It's odd. It says odd. And you can see it alternates. Thank you for the likes, you guys. And it keeps alternating between odd and even. This means the model is getting basically 100% accuracy. Essentially 100% accuracy. You can see it on the screen here. 1 and 0, 1 and 0. Isn't that cool? All the way up until all the numbers. Here you go. Look at that. It worked. It did the trick. Now, here comes the hard part. Are you guys ready for the hard part? This is where we ask the model to answer the questions on things that it's never seen before. It's never seen this before, you guys. It doesn't know. It hasn't been trained on it, but it remembers the pattern that it was trained on, so it will be able to define and predict the outcomes. Check this out. So here we go. 100. Is it odd or even? Here we go. Let me jump up here. I want to make sure to get this right on the screen. Here we go. Perfect. It says number 100. It says it's even. It got it right. It says even. So that's how that works. So you can train this, and your outputs, like you might want to say even would count as a 1, or an odd would count as a 1. But in this case, this is how we've defined it in our model. It doesn't mean you can do it other way. There's no restrictions on it. Christopher Smith. This is going over my head, but I am so hooked. Cool. That's so cool. This is the hardest thing. It is. One of the most challenging things I've ever experienced in my career is artificial intelligence and Rust. And those things are very difficult. And we combined both of them together into this. So this is Rust, artificial intelligence. And so the AI, it was trained on numbers between 0 and 100. And it knows which numbers are odd and which numbers are even between 0 and 100. But it's never been trained on numbers between 100 and 200. So it never seen that before. It's never been trained on it. But because it remembers its training from the previous 100 numbers, it is able, you guys check this out, look, it's able to predict every odd and even number going forward. Isn't that cool? You guys check it out. It did it. It worked. Odd, even. You can see What is 56? 156. It's an even number, isn't it? You guys, look, it worked. Isn't that cool? This is an AI model that we've taught to do a specific task to identify an odd. I know it's not like you could easily have an algorithm, like you say, is it divisible by 2, right? You could do something like that, obviously, and then you don't need an AI model for that. After learning hard things like Rust, does it feel hard? Yeah, it's a little bit easier. Thank you for the likes, you guys. I appreciate it. Definitely, it's so cool. Yay, I got all likes. Oh, that's so cool. I love it. Thank you, guys. Appreciate it. Oh, so great. I can see it on the screen. It's like these little floaty hearts, which is great. It's like, yeah, it is. It gets a little bit easier. MD every single time, just a little bit easier when you get going. So Rust is difficult. That's okay. Just every day, just a little bit progression. You're good to go. Same with AI. All right, you guys, we're doing the last thing of the show. K7. Hey, K7, how you go? If we go beyond 5,000 epochs, will it overfit and affect the predictions? You want to find out? Okay, K7, let's do it. We're going to make it happen. We're going to do it. Here we're going to go. We're going to go over 5,000 epochs. You guys, we're going to see. All right, here's our train the model. We're going to do it. All right, so it's currently 5,000. Let's do 20,000. Is it going to overfit, you guys? Is it going to overfit and it won't work anymore? Do you want to find out? K7, here we're going to go. We're going to do it. All right, let's bring it up here on the screen. Let's go. Here we go. We're going to redo it. Cargo run. Oh, this is exciting. Will it overfit? Will it have trained too much on the numbers between 0 and 100? Will it be too much? Here we go. We're going to find out. Here it goes. It's training. Here it goes. We can see that the loss is constantly reducing, which is good. You want a low loss, which is great, but obviously you can get to the point where it overfits, and then it might not work for future predictions, right? But in this case, I think we might have... I'm predicting yes. Hey, bro, said, hey, how's it going? Vivek, your name is very pretty. You got stars and stuff in there. Here we're going to find out. Christopher, someone from my workspace did a presentation of a model he trained to take a bunch of images and sort and place them to create Super Mario's face. Oh, that's cool. AI is amazing. It is. It's really cool. You can do so. Basically, you can do anything. We're in the future right now, you guys. We have the technology to do it. We have all the technology in the world to make anything we want. All right, here you go. K7, did it overfit? So we've got the predictions on the existing between 0 and 100. It got them right. It looks correct to me. Between 0 and 100 looks good. But here you go. Here's the numbers that it's never seen before. Check it out, you guys. It predicts even. Does it predict odd? It predicts odd. Yep, here we go. It works. It's doing it. Look, you guys. It didn't overfit. There you go. Yeah, if you get your model and you can do it, if you have a really well-defined model, it's so cool. It will do the job, and it is forgiving. It'll be forgiving, which means that you can be a little more heavy-handed on your hyperparameters, which just means how many epochs did you train, which this basically epoch just says how many times did you train on your data set. Because you've got a data set between 0 and 100, and you give the AI model all the answers to 0 and 100, but then that's one epoch. So then you retrain it again and again and again, and then eventually... Thank you for the likes, you guys. K7, it still works. Nice. Yeah, it does. Isn't that cool? It's so good. Vivek, it's midnight over here, and I'm also developing an app right now. Bro, just giving users all open source models for free to use. That's great. Yeah, definitely do that because we're at the beginning of the AI explosion, because there's so many things AI can do right now, this very moment, that nobody is taking advantage of. We can automate everything. All the existing software in the world, yes, enterprises and other businesses are currently relying on that software and will continue to do so. It is at the moment where we can easily disrupt that existing old software with new AI software that can outperform and outpace all this old software. So we're at the frontier. We are at the frontier this very moment right now where we can go out and we can write the AI version of all software stacks. It's really exciting. And there's so much you can do. It can automate everything. Everything can be automated today now with AI. It's amazing. So yeah, it worked. All right, so we're going to do the finale. This is the finale thing, the last thing that we're going to do today before we end stream. The very final thing we're going to do is we are going to do Threeven and Throdd, which we did odd and even but we want to update it to be every third instead of every other. We're going to do every third. And that will be the final thing we do. Sachin, I had a hard time with Lifetime Ellison and took a break from Rust. Okay. Yeah, Rust is tough. Definitely. Then picked up Go. Golang. Golang's a great language, and now working with it. Would love to get my hands on Rust again. Yeah, Rust. It's been a phenomenal win for us. We do have some services that use Golang at PubNub, but we are actively migrating everything over to Rust because it is that much better. Christopher Smith, do you think AI would replace us as developers? I think we're going to see short term, yes. The short term, yes, because there is a lot of productivity that we're getting with the existing coding agents. Long term, all this code is being generated like crazy, and we have to maintain and develop it. And it requires a lot more skill. Once the code is built, to maintain it and using existing models, it requires you as a software engineer who knows a little bit more than just a day-to-day coder maybe to help maintain those existing code bases. It's kind of like the movie industry where your iPhone or your phone was able to make movies easily, and so that helped explode a video renaissance. And so you suddenly had all these videos, and everyone can be a video producer, and it was really cheap. It used to cost millions of dollars because you have really expensive camera equipment, but now your phone can do it for you and at a low cost. So it's the same thing. Artificial intelligence is helping us write code for us. And so now you don't need to be a software engineer. You can write code using AI agents, and we're going to see an increase in the demand for custom software development. And yeah, we'll see a lot more software engineering roles pop up. Short term, it'll be a little bit, we'll have to wait a bit. Just wait a little bit. Okay, here, we're going to do the Threeven and Throdd, and then that will be the end, and then we will be wrapping up today. So let's see if we can get that. All right, so here we go. So we're shifting our bits. So this is our bit shift. So we all are converting it to an array, so we don't need that. We're going to do get odd even. So we're going to do this, and we're going to turn this into a Throdd and Threeven. Here we go. Throdd and Threeven. Here we go, you guys. Throdd and Threeven. So we still have to vectorize it the same. ADS. I mean, somebody has to yep, you're right. Somebody has to maintain and build the models, right? So not only from an AI perspective, which is software itself, and it requires, a significant amount of engineering expertise to do that with the AI, but the software that the AI writes will also need to be maintained. And you're totally right. The models, we're relying more and more. We definitely need to have help from software engineers on that. Okay. So that is our X train. So our Y is going to be, instead of odd or even, we're going to do Throdd and Threeven. 1 if a Throdd, and 0 if Threeven. I think Threeven. So if it's divisible by 3, essentially. So all we have to do is change this to a 3, I think. I'm pretty sure that's all we had to do. I'm pretty sure. So we did a modulus 2, right? Modulus 2. No, we just have to change that to 3, so it's a Threeven. So it's divisible by 3, right? Right, you guys? That's it. That's all we had to do. It's really simple, right? Super easy. Okay, so now we're going to underscore this so we don't get a compiler warning, because you can use, so in Rust, if you add an underscore into a function name or a variable, the compiler will assume that you mean to leave it be. It's meant as dead code or unused code. The compiler will not warn you about it. Obviously, it's a quick hack, but clearly when in your production code, you want to just delete it all. You don't need it anymore, so you should just delete it. But we're just hacking today, so we don't need to worry about it. Here we go. Throdd or Threeven. Here we go. Let's do this. Let me get here. Boom. We're going to do that. Underscore there. Okay. So that is the training data. So now we can detect odd or even, you guys. We can detect odd or even. And then what are we going to do? So we've trained the model on odd or even, or sorry, Throdd or Threeven. The subtitles, they're not going to show up correct, but it's basically, is it divisible by 3? And this is the final thing we're going to do today. I want to make sure it works. If it doesn't work, we're going to stay until it works. That's the plan. That's the plan, you guys. All right, here we go. All right, so let's take a peek here. So the model and prediction. So I want to do is, Sachin, how do you handle multi-tenancy on PubNub? Do you have a tenant identifier, a column? Yeah. So we have API keys. How do you make sure the data doesn't leak from one company to another? We do sandbox isolation between API keys, which defines the scope or the memory segments that are responsible, dedicated to you're in a multi-tenant system. You need to be careful that, right? So Sachin, you bring up a really good point. When you have a multi-tenant infrastructure, customers' data is co-located. It's co-located. That means the data is right next to each other. But you don't want one customer to be able to see the other customer's data. And so you have to create isolation in data. And so we have tenant IDs. For example, you always add where tenant ID is X, all database queries. Yeah, exactly. So we have tenant IDs. We have multiple types of tenant IDs. We have a tenant ID for the API directly, and we have tenant IDs that are defined as customer objects in our database that represent management of the API keys. So we have multiple tenant IDs. Yes, you're totally right. And that's how we manage multi-tenancy in PubNub. There you go, in PubNub, yeah. Here we go. All right, so, yep, you're totally right. Tenant IDs, that's the way to do it. All right, so now we have our Throdd and Threeven, and we built the model, we trained the model, and let's test it on these numbers. So what I want to do is, all right, so we have to re-encode 0 to 100. Looks good. But here we go. How do we get so we don't need to. I think we did it. Okay, so here. Here we go. I have to change these. Let's see, this will be Throdd. Well, we got to make sure everything's typed in right. Throdd. And then, actually, here we go. That Throdd. And then we go Threeven. Here we go. We got to spell it right. Threeven. Perfect. Is it Threeven? Yeah, Threeven. Here we go. And then, is there any other odds or evens in here? I want to double check. Actual odd, even. I'm going to leave the variables the same. Even though we know that they're not odd and even. Throdd to Threeven. Okay, looks good. Is there any others in here? Get Throdd to Threeven. I think that's it. All right, we're going to try it, guys. You're going to try it. Here we go. Is it going to work? Do you think it's going to work, you guys? I don't know. I don't know if it's going to work or not. We will try it out. Cargo build. Let's just see if it compiles. It compiled! All right. Woo! All right, let's get rid of that warning really quick. So 117. Here you go. And then you just go underscore, right? Remember we learned that you could put an underscore and then cargo build. Cool. And that gets rid of the warning because it's something unused in the code. There we go. All right, here. Is it going to work? This will be the last thing of the stream that we do today, you guys. This is the last thing. So we'll do cargo run. We'll see if it learns. It's learning. You guys, it's learning. Oh, is it going to work? It's probably going to work. I mean, you can see the loss. It's decreasing. It's ever decreasing. It's decreasing just a smidgen every bit, which means that it's learning. It's learning to recognize numbers divisible by 3. Isn't that cool? We're teaching an AI model. I know this is like very basic stuff, like super basic. It's super duper basic, but it's a lot of fun. All right, did it work? All right, here we go. I'm actually super curious. So what we should see is a Threeven number would be 0, and then a Throdd, which is like not divisible by 3, will be 1. And if it's close to. So what we should see is basically every 3. Okay, perfect. You guys look. It looks like it works. I do see it's working. 1, yep, 0, 1, 1, 0, 1, 1, 0, 1, 1. It's working, you guys. Check it out. All right, we trained an AI model to recognize Throdd and Threeven numbers. Isn't that cool? All right, the final test, you guys. The final test before we end stream here. Here you guys go. The final test. Can it recognize numbers that it was never trained on? Is it going to work? I don't know, you guys. I don't know if it's going to work or not. The answer is right here on screen. I'm about to reveal it. Here we go. Let's take a look. All right. Throdd. Predicted Throdd. Predicted Throdd. Wait. Predicted Threeven. Wait. Is it? Actually, hold on. I don't know. What they realize. Thank you for the likes, you guys. It looks like it's working. It's supposed to be Throdd, but it predicted Throdd. It's supposed to be Throdd. Predicted. It's supposed to be Threeven. It works. You guys look. It worked. We did it. We succeeded. Oh, there we go. That's like the ultimate thing that we wanted to do for like the past few streams. We did it, you guys. We did it. All right. We did it. We trained the AI model on the ability to recognize divisibility by 3. Yes, I know. For real, like if we're really thinking about it, you can easily create a function that is very basic and logical in code. And look here. This is overkill. It's an overkill algorithm. Thank you for the likes, you guys. I appreciate it. We did it. But yeah, if we wanted to have it like in real computer world, yay, we did it, you guys. Thank you for the likes. We've succeeded. Don't see it all, but congrats. Cass, hey Cass, good to see you. Didn't see it all. Yeah. Okay. So Cass, what we did was we have from scratch, we wrote our own deep learning neural network in Rust. Like only scrolled in here now. You just came in now. You came in at the right moment because we succeeded. We finally did it. We trained an AI model to recognize. This is a toy model, so but it's still really cool to recognize divisible by 3. That's what we did. We recognized divisible by 3, and it worked. We trained it, and here's the cool thing: it can see. I appreciate all the likes, you guys. It can see numbers it's never seen before. It can predict the correct answer. So we trained it for recognizing divisibility by 3 only on the first 100 numbers, so 0 to 100. So we trained it on 0 to 100, and it remembers all those. And it found a pattern. Isn't this cool? It found a pattern that can recognize numbers it's never seen before. And that's the whole point of AI, right? If you're in here and you want to train AI, you want to train it on a specific set of data set, but then you put it into production in a system, in a place where essentially is what humans can do is they can recognize a pattern and see, hey, I remember this pattern, but I've never seen it like this before. This is weird. Oh, look, isn't that crazy? Sachin is so cool. We did it, you guys. It can recognize a pattern even on data it's never been trained on in its entire life. And that's like the point of AI. That's like the whole point is kind of like emulate and mimic, the human ability to recognize those patterns and apply them to situations it's never been in before. And it gives it the answer. And so now you've written like artificial intelligence. And isn't that cool? That's what AI is. Thank you for the likes, you guys. We did it. And so we trained it. And so thank you. It's so cool to see. I'll appreciate that. I see the icons floating up. It's so cool. Appreciate the likes and all the interactions. It's so cool. We did it, you guys. We achieved the goal of the stream. And yes, I know you might be saying, hey, Steven, wait, hold on. You can just write a function that detects detects odd or even like this. Watch. Detect odd or even, right? Look at this right here. Like, no, it shouldn't be that. It shouldn't be that. No. Here, let's get rid of this. Hold on a second. Let's get rid of some of that. Get odd or even. Boom. All right. There we go. Not get XOR. We don't want to get XOR. Odd or even. Here we go. Underscore even. Okay. Check this out. And we say it's a number, an F64. So we can do something like, let's take this number. Here we go. Perfect. Look. Okay. This AI ML seems interesting now, doesn't it, MD? You can train it to do whatever you want. And here, I know, you guys, I know. This is the code that we basically trained the model to do. It's that simple, right? And we trained it on Throdd or Threeven. So Throdd or Threeven. Here you go. Like that, which basically is this function here. No, let me increment by 1. There we go. Perfect. Let me say Threeven and Throdd. There you guys go. So this is what we train the AI model. I know you guys, I know what you're saying. It's a simple algorithm that you can solve in regular computer science using a simple function. But that's the whole point. We're learning today. We're trying to understand how AI works. We're training the model using custom code from scratch, and it's able to predict the future. Hey, Roshan. Hey, Roshan. Hey, good to see you. You came here. We just finally, we did it. We succeeded. We trained the AI model on numbers. It's able to predict if it's divisible by 3. And yes, I know you might be saying here on the screen, this is a simple function, but we wanted to make sure that it could do it for all future numbers that it's never seen before. And it works. We did it, you guys. All right, that achieves our goal for the stream. Thank you so much for joining. If you have, if you want to, so we go live every day, but not at the same time every day, and only on the weekdays. And so we have here a Discord. So I'll paste you a link. So if you want to jump in and also chat and hang out with us on the Discord, we are here at the Discord. Also, subscribe to get the notification when I go live, because I don't go live at the same time every day because I've got meetings or other things happening. How much time will it take for you to learn Rust in 1 month? Easily in 1 month, you'll be able to do it, MD. MD, in 1 month, you will have no problems. What will you be building next? Okay, so in our Discord chat, we have a bunch of ideas that I had around here somewhere. I'll have to find them. But we can do cryptography. We can do more Rust algorithms. We could do messaging, communication. We could do operations. We could do Docker containers. I mean, there's so many things. If there's something that you really want the next stream to be, tomorrow's stream, make sure to post it in the Discord. Put it in the Discord, and we can make that tomorrow's stream. So yeah, definitely put it in the Discord. Otherwise, I'll come up with something that feels. Oh wait, what's going on? Hey, Drawing Brothers. Hey, we're just ending stream. We're just at the end here. We are wrapping up. We just finished our code to detect divisible by 3. We trained an AI written on custom Rust code. That's just from scratch without Sachin, communication. Yes, absolutely. Oh, communication. That's a good one. That's a good topic. We can do communication for sure. I definitely want to follow along in the next one. What do I need to set up to be ready? That's a good question. It really depends on what our next topic is going to be. What is the next topic going to be? I'm not sure. We've been doing Rust for the past week, but we can do Python or JavaScript or Swift or Kotlin or do cryptography, right? Cryptography. We could do lots of things. There's like a lot of different things we can do. But once you learn Rust, you will give a very big party to ants. All right. That sounds like a good plan. Absolutely. So if you want, I'm not sure. We'll figure it out. So join the Discord, which I pasted a link in here. I'll paste it again really quick for you guys in case you didn't notice it. Join the Discord and ask for Golang. We could do Golang. We can absolutely do Golang as well. So we've got Go. We can get Go installed in here. Subscribe. Thanks for all the awesome explanations. Absolutely. K7, it was great to have you here. So we're wrapping up the stream now. Feel free to subscribe or join the Discord so we can figure out what we're going to talk about tomorrow. What's going to happen tomorrow, you guys? I don't know. I'll be, what is this? Easy Shutter. Hey, how's it going? We just finished. We're wrapping up stream here. We created an AI model written in Rust that detects divisibility by 3. I know it's a simple thing, but it's a lot of fun because assembly. That's a good one, Drawing Brothers. I actually kind of want to do assembly. I think that would be a lot of fun. Just like some basic getting started stuff with assembly, because I haven't used assembly much in my career, but I do know some basics about it and would be fun to mess around with assembly. I think it would be fun to get a compiler running locally that can take assembly language, but there could be some danger zones there, because I think if with assembly you can be super dangerous, right? Even with C, because now you're full control of the operating system, everything going on, you can crash it. We might crash, you guys. The stream might crash if we do assembly and we try to compile it locally. Isn't that crazy? Do you teach Python? Yeah, we can do Python as well. I love Python. Python's actually one of my favorite languages because it's super easy to read and write. And it's simple, and there's not a bunch of fancy symbols everywhere. So it's super simple, and that's why I really like it. That's why I really like it, you guys. Here we go. Let's see here on the screen. This cargo run. Let's retrain the model. Look at this. Check it out. Using multiple cores, but probably just one core. Rust for machine learning. Yeah, that's right. That's writing bismuth, Rust for machine learning. Absolutely. That's what we did. And all from scratch too. Just using ND array. And that is just one dependency. That's it. That's the only dependency we use, just for some easy math. That's it. Yes, please. Christopher. Yes, please. I've never used it. Would be fun. Christopher, which Golang or Christopher, before we go, Christopher, were we saying Golang or assembly? Were you thinking Golang or assembly? Imagine, oh, no, assembly. I got it. Imagine we crashed the stream. Okay, let's do assembly. We'll do assembly tomorrow. That'll be fine. Really like I can crash the OS. You with C, you can crash the OS with C2. You can access memory where you shouldn't be. You're trying to learn. Easy Shutter, you're trying to learn it and would love some vids on it. Absolutely. Rust. Okay, so here you go. Do this real quick. Check this out. Go to this Rust by example. And if you click on videos here at the top of the screen, look who's at the top of the screen, you guys. Check it out. That's me. That's where we are. Rust by example. Check it out. And we've got some videos on YouTube, and we go through all the Rust by examples. We're the number one. Isn't that cool? We're at the very top. I love it. I love to see that. So that'll give you the answer to that. Some good YouTube videos, but there's also Rust by example, and you can, here we go. There's this here, Rust by example, and there's easy hello world stuff here. And this is what we do in the YouTube video. We go through this in the YouTube video. So this is how it works. And then we just, click the play button. There's compilers built there right into the browser. You click play and it outputs right there. It's really cool. Really easy to learn. It's a really great way to do it. If you write data to registers and memory addresses with caution, no need to worry. Yep. Don't need to worry about that. Just randomly write stuff here and there. That's what we're going to do. All right. So we'll do assembly tomorrow. We'll have like a very simple project. Maybe we'll try to do something like multiply numbers. Maybe add some numbers together. We'll try to keep it simple. That'll be the plan. Got to keep it simple. Got to keep it simple, you guys. Not, only Python, not Rust. Oh, Easy Shutter. Python. Yeah, there's other Python resources as well. There might be Python by example. Is there Python by example? Python by example. There might be as well. Yep, learn Python by example. So this is also a good one. You can do that as well here. Really simple. I don't know if it's got a built-in compiler though. I'm not sure if it got built-in compiler or not. But yeah, that's the plan. All right, so the plan for tomorrow, you guys were in stream here. Excited? Yeah, me too. We'll try not to crash stream. But if the stream crashes, you'll know why. Because we did something in assembly that we shouldn't have done. Cool. Would you tell me the resources for Python? Yeah, I think this would be a good one right here. But also, if you join our Discord, join the Discord. We also have some, there's an item on the Discord that someone posted earlier. Let me see if I can scroll up to it. Here we go. Here we go. Here, a nice list of Python. Here we go. So this is an O'Reilly book that they were recommending. An O'Reilly book, Fluent Python, 2nd edition. There you guys go. Excited. Yeah, I'm looking forward to it. Thank you guys for joining the stream and headed out now. We're leaving. We're actually leaving now. We'll be back tomorrow. And join the Discord or subscribe to get the notification when we go live. Because there's no set schedule. We don't have a set schedule. But I'll see you guys tomorrow. Thank you for joining the stream. Bye everybody. We're headed out. We're actually clicking the goodbye button. Adding numbers, that will be easy. A great way to start. When will you do? Tomorrow. I don't know what time tomorrow, but around the same time probably. But maybe a little bit earlier or a little bit later. Maybe a little bit earlier. I'm not sure. It depends. I have to look at the calendar. But we'll tell you in the Discord when we are about to start. Have a good one, brother. Cool. See you guys. Headed out.